Here's another vector problem, continuing what we did in the first video. We want to find the magnitude and direction of this vector, -4, -3. Let's go ahead and draw a picture of it so we see what we're dealing with here. So -4, -3. So right there is our vector. Okay, and we want the direction and the magnitude of this vector, if this vector is equal to u. Okay, so that's what we're looking for right there. We know that this side is -3 and this side is -4. So the first part's the same as what we did before. The magnitude of u is going to be equal to the square root of -4 squared and -3 squared. Okay, order of operations, remember we're going to square that whole thing. So we're going to have 16 plus 9, and of course the square root of 25 is equal to 5. So magnitude of u is equal to 5. Okay, and then we have tangent theta is equal to opposite over adjacent. So -3 over -4. And we're going to do tangent inverse here. And of course negative over negative is positive. So we've got tangent inverse of 3/4. Alright, now when we put that into the calculator, we're going to get 36.9. Okay, but we've got to look at the picture and remember that the calculator is actually going to give us our reference angle. Okay, 36.9 obviously cannot be our answer because that would put us in the first quadrant. We need a third quadrant answer, which means we need 180 plus 36.9 to get over here. So our actual theta is going to be 180 plus 36.9 to get us into the third quadrant. And so that is going to give us, let's see, that should be 216.9. 216.9. Okay, so there's our magnitude and our direction. Okay, let's try another one. Actually, before we try another one, let's look at this again. Back to the original. Okay, so here's our AB. Here's our theta. Alright, now, if we look at this, let's see, this is A, this is B. Alright, if we look at this from the standpoint of the horizontal and vertical components, alright, then A, well, let's say it this way. Cosine of theta is going to be adjacent over hypotenuse, and we know the hypotenuse is the magnitude of this vector u. So cosine of theta is going to be A over the magnitude of the vector. Or in other words, magnitude cosine theta is equal to A. And by the same reasoning, sine theta is opposite over hypotenuse. So u sine theta is equal to B. Okay, so in other words, we could write the vector as u cosine theta, u sine theta. Alright, so that's another way to look at it. So now let's say that we want to find the horizontal and components of u. So that's the A and B. Okay, so find the horizontal and vertical components of u if it has magnitude 56.1 and the direction theta is equal to 104.5. Okay, so we're going to use we can use what we just did above. So this time we have the magnitude and direction, and we want to figure out the vector. Okay, so the horizontal and vertical components. So we can draw a picture if you like. You actually don't really need a picture for this one because it'll just work out. Okay, so there's our theta, 104.5, and our magnitude right here is 56.1. Okay, so A is going to be equal to magnitude U cosine theta, and we're given that. So the magnitude is 56.1, and theta is 104.5. So we've got 56.1 times cosine 104.5, and that should give us negative 14.0. So our A is negative 14.0, and that makes sense because we can see from our theta, we're going to have to be in the second quadrant. That's going to have to be negative to put us in the second quadrant. Okay, doing similar for B, we've got U sine theta. So that's going to be 56.1 sine 104.5, and that is going to be equal to 54.3. Okay, so this side is 54.3, and that makes sense, negative, positive, that puts us in the second quadrant. So we could write the vector as negative 14.0, 54.3.